let's do a quick recap now. I don't want you guys to raise your hands, but I do want you to like quick fire in the chat. Give me what we said the formulas were for these four shapes to calculate the area. So just type it in the chat. Square, what is the formula? Let me have a look. Okay, we have a rectangle, cool. Hi, Pamela. I'm so glad that you've told me that you're new. I love, love, love welcoming new students. Is Pamela your actual name or are you using somebody else's account? Oh, there we go. Finally. Sorry, I'm only joining the lesson now on my tablet. But I'm looking at the chat. So we have a square, we have a rectangle, we have a triangle, and I think I saw, what are we missing? The circle. Has nobody, there we go. We have the circle. Cool. So Pamela, you are joining us at the end of our series. So it is a little bit of a bad time, but you should still be able to follow along. So we're dealing with area right now. We are looking at the formulas to calculate. It's Kia. Hi, Kia. Glad to see you in class. Oh boy, I'm having so many issues today. There we go. It's Kia. Okay. So let's now write in these formulas you guys have given me. So when we're looking at a square, the area to calculate, no, the formula to calculate the area of a square is side times side, which we can simplify to side squared. When we are looking at calculating the area of a rectangle, we know in a rectangle, we have two different lengths. So we have these two sides that are equal and we have these two sides that are equal. So we can't just say side times side because when we use the same variable, it implies that they are the same length. So what we're going to do now is we're using two variables which are different to each other, and that is length times breadth. When we have a triangle, we have the formula for the area, which is equals to half my base times my perpendicular height. When we talk about perpendicular height, it's super important for you guys to know the perpendicular height is the line that you can draw from the tippy top of the triangle down to the base of your triangle. And that line must create a right angle in between the height line and the base. So if you have a triangle that looks something like this, and you're trying to calculate the height, remember all you have to do is extend your base and you can then draw your perpendicular height line. So remember, guys, our height in our triangle is not going to be this. This is not the height in my triangle. Please, please, please don't make the mistake of using your slanted height as your perpendicular height. In my formula for area of a triangle, we specifically want perpendicular height. So that is a triangle, and then we have a circle. So the area is pi r squared. Remember, because area is squared units, we always use the formula for a circle that has the square as well. That's just an easy way to tell the difference between the perimeter or the circumference and the area. Cool. So are we all comfortable with using these formulas? I would hope so by now that we're all comfortable with these. Let me know if you're still struggling with one of these formulas. Also, let me know so that we can talk about it. Okay, cool. Let's move on. So, what we did on Tuesday was very much the basics, where we were always calculating our unknown as the area. What I've put up on the board now is some examples where they've given us the area and we have to work backwards to calculate a missing length. So here they tell us the area of a square is 42.25 centimeters squared. Determine the length of the sides of the square. Immediately, I'm gonna go ahead and I'm gonna try and draw a square just so that I'm getting the picture. And I know they've given me the area and they told me the area is 42.25. Um, so what do I know about a square? I know that the formula for the area is side squared. Now, when you look at this equation, I want you guys to be very aware that this formula is an equation. And if you were with us when we did our series on equations, you should know that equations can be manipulated. You can always solve for an unknown in an equation if you have any other information. So whenever you have an equation and there is an unknown, you can always solve for it if that is the only unknown in the equation. And right now, I know they've told me what my area is. So my only unknown is the length of my sides. So I'm going to plug this into my, I'm going to plug what they've given me, 42.25. I'm plugging that into my formula. I now have that 42.25 is equals to my side squared. Can somebody tell me what is the next step? What do I have to do now? A hand, Itandile, yes.
Good afternoon, ma'am.
Afternoon.
Ma'am, I'm thinking, so please, I'm thinking. We have to square root
Mhm.
both.
You are very correct. Remember, guys, the whole objective of an equation is to get your variable by itself. And the only way we can get our variable by itself is by using inverse operations. So what we do here is we square root this side. Why are we doing that? So that my square and my square root cancel each other out. But now because I've square rooted one side, I must square root the other side. And then Itandile, if you're still with me, tell me what it is you're getting.
Ma'am, I'm getting 6.5 centimeters.
6.5 centimeters. Now, it's super important to note that this is just centimeters because it's the length of a side. So the length of my side is not going to be in units squared again. It's just centimeters. Thank you, Itandile, for helping me do that one.
It's my pleasure, ma'am.
Cool. So that was that. Before I move on, I want us to check in with each other. Let me know how we felt about that. Did that one make sense? Okay. I see some thinking faces, but I don't know if that was just a mistake because I also saw thumbs ups from the same people. And then I literally just put in this highlighter so you guys could focus on one at a time. So we now have the area of a square again is 90.25 centimeters squared. Determine the length of the sides of the square. Anybody want to help? Let's see. I saw hands. I just don't know who was first. We have Emitle. Yes, answer for me.
Afternoon, ma'am.
Afternoon.
So, ma'am, what we're going to do is we're going to write area equals side squared.
Okay, so area equals side squared. Yes.
And then we're going to say 90.25 centimeters squared.
Mm-hmm.
Wait, 90 is equals to s squared.
Mm-hmm.
And then we're going to square root sides so that the square root and the square and the square will cancel out. And
Mm-hmm.
then my answer is 9.5 centimeters, ma'am.
9,5 equals to side, so we can say, therefore my side is equals to 9,5 centimeters. And I want you guys to see, remember this was centimeters squared, but we also square rooted that. So that square on my unit also sort of gets square rooted, and we're only left with centimeters. Thank you very much for that one, Emilia.
Thank you, ma'am.
Okay, and then we have our last one here on this page. It says the length of a rectangle is triple its width. If the area of the rectangle is 27 centimeters squared, determine the length and width of the rectangle. Now, I very specifically remember us doing something similar when we were going through perimeter. So if somebody wants to help, you definitely can. Immediately, your hand is still up,
I'm
or
gonna
is
try, ma'am.
done dealer? Okay, immediately, let's go.
So, ma'am, what I think
Mhm,
we're gonna do is we're gonna take an area
mhm,
width, which is 27, 27
mhm,
centimeters squared, and
mhm.
then I think we're gonna so wait, so since the area of a rectangle is length times breadth,
Mm-hmm.
I think we're gonna divide.
Okay, let me help you out, Emilia. What I want you to see is, do you see there are two variables that are unknown in this equation?
Yes, ma'am.
Can we solve an equation when there's two variables?
No, ma'am.
No, right? We have to have only one unknown. So even if I plug in this 27 that they've given me into my formula, I'm still going to have two variables that I don't know the answer for. So what I need to do is I need to figure out how to get rid of one of these variables. Now they've told me that the length of a rectangle is triple its width. What does that mean? It means that my length is equals to triple my width. Are you with me?
Yes, ma'am.
Okay. And
So I
remember,
think
do you remember what width is, immediately?
yes, it's the same as breadth, ma'am.
It's the same as breadth. And so what variable can we use for this?
W, ma'am.
We
I
can use
think
W, right? Because this is the width and my length is actually triple my width. So we've now basically written our length. We've written our length in terms of my width. Well, let me undo that. We've written it in terms of our width. Would you now maybe be able to try again immediately and tell me what are we doing now?
yes, ma'am. I'll try. So I think we have to divide the.
Okay, so substitute for me first.
So it's gonna be 27
Mm-hmm.
equals to 3W times W.
Beautiful. Now what?
So then we're gonna swap them around, and so we're gonna say 3W
Mm-hmm.
is equal to 27, and then we're gonna
Okay,
do.
but what is happening to this
Oh, wait,
W over here?
we're multiplying it with 3W.
So what is 3W times W?
3W, man, because like there's an invisible 1 in front of the W.
Yes. Okay, so you're right. Remember now, Initha, when we're multiplying, okay, when we're multiplying, we have to use S, N, V. So let's multiply the signs first. What are the signs here in front of both of my terms, or in front of both of my numbers here?
W, ma'am.
The sign. So we're looking for the sign, remember, plus or minus?
Oh, they're both positive, ma'am.
Right. So a positive times a positive gives me what?
A positive, ma'am.
A positive. Now let's multiply the numbers. And there you've done it beautifully, and you've told me 3 times the invisible 1 over here gives me what?
3, ma'am.
3. And now what our last thing is variables. We now have to multiply my variables. So what is W times W?
W squared, ma'am.
It is W squared. So always super easy to forget that. But don't always remember you have to use SNV. Wherever you are multiplying these terms where there are variables and signs and numbers or coefficients as we call them, it's always safest to use SNV. That way you never, never, never miss anything. Okay? Cool.
And so
So
we're
now
gonna
we have
say
that this is 3W squared. What next?
we're going to square root both of them, ma'am.
Okay. Before we square root, there's something we have to do.
Oh, divide, ma'am.
We have to divide because remember, this 3W squared really means 3 times W squared. So we can't deal with something that's directly attached to my variable as yet because I still have something that can be removed before I get here. Does that make sense?
Yes, ma'am.
So you sort of want to deal with things from the outside first. So if it's like an apple, you are biting outside the apple until you get to the core, which is your variable. Right now, you can't deal with the core because you still have a coefficient around there. So you have to
Yes.
remove that coefficient before you can actually get there. Make sense?
Yes, ma'am.
Cool,
So
cool.
we're first gonna divide both of them by 3. So then
Beautiful.
9 is equal to W squared.
Mhm,
And then we're gonna square root them. So then
mhm.
I got 3 is equal to W. Therefore, W is equal to 3.
Okay, therefore W is equals to 3. Am I now done?
No, ma'am, we still have to say the the length
Mm-hmm.
is equal to 3 centimeters.
Is equals to 3.
3 centimeters, ma'am.
Okay, where did you get that from? Are you just saying that your length is equal to your width?
Yes.
Remember, if you're saying your length is equal to your width, then that makes this a square, which we are not dealing with a square. They've told us it's a rectangle. So my length and my width cannot be equal to each other. Do you see that?
Yes, ma'am.
What did we say my length is equals to?
3 times triple the width.
Right, it's triple the width. So my length is going to be 3 times my width. And now I know what my width is, and that is 3. Do you see that?
Yes.
Cool. And now what is my length equal to?
9, ma'am.
9 centimeters. Now, immediately, I want you to see how this makes sense. If we were to look at the area of this, do you agree we would say width times length or length times breadth, and 3 times 9 does give us 27. Do you see that?
Yes, ma'am.
So you must always make sure when you're doing these questions, immediately you should have known the length cannot be 3, because if I went 3 times 3, it only gave me 9, which is not equal to what my area should be. Make sense?
Yes, ma'am. Yes, ma'am.
And that is that. Thank you very
Thank
much,
you, ma'am.
Inez. Okay, guys, that was a bit of a long one. If you don't remember doing this one for perimeter, I'm so sure that we did do one very similar to this. I think I even took the exact same question and just changed the area of it, obviously, from perimeter to area. So go and have a look at that, rewatch the video if you must, so that you really, really, really get a grip on these types of questions. Before we move on, though, I will take questions that you guys have. So if there are any questions on any of these that are on the board right now, please take this time to ask. If not, you can maybe give me a thumbs up with your reaction so that I know that we're all good and not still typing out our questions. Okay. And by the way, guys, I am reading your answers in the chat. Okay, Emihle, let's hear your question.
So ma'am, like this week we had like revision with one of our other teachers for maths, ma'am.
Mm-hmm.
So now we would wait, no, last week. So ma'am, like one of the questions was like calculating the area of
Mm-hmm.
like it was a semicircle and we had to calculate the area, ma'am, and I was a little confused with it, ma'am.
Okay, so that's a very good question. When we have a semicircle, what's the difference between a circle and a semicircle?
The semicircle is half of the full circle, ma'am.
Right. So what will be the difference between the area of a full circle and the area of a semicircle?
The area of the semicircle will be half of the area of the full circle.
Exactly. So this semicircle over here is quite literally half the area of a full circle. So what is the area of a full circle, Emihle?
The formula is area equals pi r squared.
It's equals to pi r squared. Now, if we want half of this, there's two ways we can take half of this. We can either divide it by 2, or we can take that pi r squared and multiply it by a half. Multiplying by a half and dividing by 2 is the same thing. So now we've actually now gotten sort of a formula for the area of a semicircle. Does that make sense?
Yes, ma'am.
Even if you had a quarter of a circle, all you had to do is take your area of a full circle and divide it by 4 or multiply it by a quarter. Does that make sense?
Yes, ma'am. Thank
So
you,
when you
ma'am.
have an area of a semicircle, do not stress. As long as you know the area of a full circle, all you have to do is divide it by however many pieces you have been given or multiply it by that fraction that is given. Make sense?
Yes, ma'am. Thank you so much, ma'am.
Pleasure. Moving on, we have a composite shape. If you don't know what a composite shape is, it is when we have a shape that is not one shape on its own. It's made up of a combination of multiple shapes. Now, I know a lot of us tend to hate these composite shapes, but really it's not so bad. The first thing you're going to want to do is you need to sort of break up your shape. Now, for perimeter, it's different because you don't always have to break up your shape. But for area, we have to break up the shape. For area, you are always going to want to break up your shape. So immediately I'm seeing I could break it up like this into 3 different shapes. So this would be rectangle 1, rectangle 2, and rectangle 3. But that's a lot of rectangles. So let's try again. I see that I could just section it off over here and make this rectangle 1 and this rectangle 2. Yes, Dimitri, we 100% can split the shape. Now, the way that we split it is going to depend on the information we've been given. So if I have enough information to keep my shape split like how I've labeled it here, then I'm going to do that. The only information I need is I need to be able to calculate the area. So these are going to both be rectangles. So I need the length and I need the breadth of both rectangles. So immediately here for my rectangle number 1, I see the length and I see the breadth. For rectangle number 2, what I'm seeing is I can calculate the length. How am I going to calculate the length? Well, if this top line is 15, then that means that this line must be 15 minus this 4 minus this 4. Okay? I see that I can also calculate the breadth by taking the full 9. Uma, I think that looks like you. Yes, Uma.
No, ma'am, I want to answer, ma'am.
Okay, sure. Let me finish explaining this and then I'll call on you to help me do the actual calculation. So now that I've got this, I can see I can actually calculate the length of this line. How? I know the full line is 9, and I know this little bit at the top was 6. So I can say 9 minus 3. Did I say 6? I did say 6. The bit at the top is 3, I meant. So what I can do is I can say 9 minus the 3 at the top is going to give me the remaining 6 centimeters. So immediately I have enough information to keep my rectangle split like this. And so I'm going to move on, and I'm actually now going to start calculating the area of each one. Now, super important is when you have these composite shapes, when you have these composite shapes, you must differentiate between your calculations. So if I'm going to calculate the area of this top rectangle, I must label it as area of rectangle 1, area of rectangle 2. And only at the end I can say area of shape equals, because your teacher must be able to follow along with the calculations you're doing. You can't just put your calculations anywhere and, not say what you're doing. It's too confusing. And as a teacher, we're going to give you 0. We're not going to be bothered to follow through with what you've done. We're just going to give you 0. So it's super important to learn a neat and correct format. Now, there isn't one correct way, but what you should work on is making your calculations neat and understandable and easy to follow for somebody else. So, Uma, you are up. Tell me, how would you do this question?
Yeah, so I can see the line over there, and I can see that 4 is equals to the other side, so we know that side there is 4, so you can add the other side again. So now I'm gonna say 15 minus 8, because you want that dotted line over there.
Beautiful, yes.
And 15 minus 8 is 7, so we can add that to the diagram.
Okay, so let me just tell everybody what you did. Uma is saying this entire purple line here is 15 centimeters. Why did he minus 8? Well, 8 was the 4 and the 4. He just added the 2 sides because we were minusing that to get the missing part, which was in the middle, which was 7 centimeters. Carry on, Uma.
So now we can see that the length from up over there and down over there is 9 centimeters.
Mm-hmm.
So the 3 centimeters over there is blocking, like, is not, like, you just have to subtract 3 from 9 to get that part over there. So you find out that's 6 also. Both sides are going to be 6.
Mm-hmm. Correct.
So automatically I know it's a rectangle because I can see it.
100%. We see that there are 2 opposite pairs of sides that are equal.
So I'm gonna say area of full shape is equals to area of big rectangle minus area of small rectangle.
Okay, so area, which one is the big one?
The one with the 15 centimeters.
So area of a rectangle 1, and you're saying minus.
Ma'am, I said plus.
Okay, you did say minus, but that's okay.
Ma'am, you heard nothing, ma'am.
Okay, you're right.
I think
don't know
it
what
was
I'm
just
talking about.
your brain saying that it was a minus. Yeah.
Okay, so that's correct. That is a very logical way to set it out. What next?
So now I want to calculate the area of the first rectangle. So I'm gonna say area is equals to length times breadth.
Okay, so I'm starting a new calculation now.
Um, yeah, that's equals to L times B. Then I'm gonna say 15 times 3, and that is 45. Yes. And then the area of rectangle 2 is L times B. It's L times B again. 7 times 6, and that is 42.
Mm-hmm.
Now we can just add 45 and 42, and you're gonna get 87 centimeters squared.
Thank you very much, Uma. 87 centimeters squared. My only advice to you is to maybe put the step last. So if you were ordering your steps, calculate each one individually first and then do the whole thing at the end. But this was perfectly okay the way you did do it. It still made sense. The other format I want to show you guys that you could do is you could have done it like this from the beginning. So I just want to copy this. So you could have said the area of the shape is equals to the area of rectangle 1 plus the area of rectangle 2. And you literally could have gone length times breadth plus length times breadth. And you could have gone, this is going to be what was 1? You could have gone 15 times 3 plus 7 times 6 equals to 45 plus 42 equals to 87 centimeters squared. So we could have done that. This is another method, or not really a method, but another layout that you could have used. Obviously, a shorter layout, but just a little bit more difficult to understand if you're getting confused easily on that. So that is that. I do want to show you guys something else we could have done. Now I'm going to show you a different method completely. So what we did was we broke this up into shapes. Sometimes what you can do is you can say, well, this previously was a big rectangle over here. So what I could do is I could go area of big rectangle. I could do that, but I'm actually going to say area of full rectangle. The area of the full rectangle would have been length times breadth, which would have been 15 times 9. Let me know in the chat, you guys, what are you getting when you put into your calculators 15 times 9? Ma'am, I forgot squared for the second one. Oh, thank you, immediately. I did literally just fix that. 15 times 9. I just put it in. Tell me what you guys are getting. Itandile, check your calculation. It must be 135. There we go. It is 135 centimeters squared. Now, what I can see they did is they cut out these two little rectangles from the full rectangle. So what I can do is I can then calculate the area of this rectangle and this rectangle. I can see the identical rectangles. So I can calculate the area of one of the rectangles, multiply it by 2, and then subtract it from the full rectangle. So let's look at how that would look. My area of my small, or well, let's call it area of cutouts. The area of my cutouts is length times breadth, but because there's 2 of them, I'm multiplying it by 2 as well. My length over here, remember Uma told us how we calculated this? It was 6. So it's going to be 6 multiplied by, we then calculate, no, not calculated, we then were given that this length is 4. So 6 times 4 times 2. Okay, so where did I get that? I was calculating, or I am calculating, the area of this rectangle over here. Okay, So this is what we're calculating. The area of this rectangle and the area of that same rectangle on the other side, okay? So that's what we're calculating now. That is why I used 4 and the 6, because those were the measurements that were applicable to those little rectangles. Now that I go and I've done that, it's going to be 6 times 4 is 24 times 2, and I'm going to get 24 times 2, which is 48. There you go. You guys are in the chat with the answers. Thank you very much. And then my final step, and I want to almost zoom out just so that I can put, no, please. Oh, Lord, what did I do? Let's try that again. Hello. Okay. I'm gonna do that. And then I'm going to move that up there. So, a lot of methods I'm showing you guys for this little one diagram. It is basically already time, which is crazy. So this is now going to give us 48 centimeters. And now the area of my shape. Beautiful, Itandile. Oh, that's what you were giving me. You were giving me 135 minus the 48, which gives me 87. Okay, guys, let me know how we're feeling about this. So we have one method over here. So we have method 1, which is this, and then we have method 2. This over here is just a different layout style of method 1. Cool. I saw your showers of thumbs ups. I very much overestimated how much work we were going to get done today. So I think I'm like literally taking one hand per block thingy, my Bobby. No ID. Okay. Itandile, Imihle, Liako, Umar. You guys will be our answerers of today. I don't know who wants to go first, but I'll just take Itandile's hand. Your hand is up first.
People gonna hate me, but ma'am, I like history.
Oh my gosh, that's crazy.
Although
Same.
because ma'am, it's storytelling. I don't have to
Oh,
study.
you're right.
I don't have to study. I just storytelling. I don't have to study.
Yeah,
I
no,
can
that's
just know
crazy.
Jan van Riebeeck did this, that, and the other, and I write it on an essay paper, and I'm done. Although I'm
But
going
you
into
have to
physics,
memorize all of that.
I'm not gonna memorize, ma'am. I just have to read storytelling. Done.
Nice.
Although I'm going
Liao,
to
I'm
be,
with you. I agree
although
with
ma'am,
Liao.
I'm going to be a physician, but history, I'm done. Have to study.
Okay, Tangeli, it honestly matches your personality, so I'll take it. I will take it. Thank you for answering. We are moving on because we don't have time today. We have 30 seconds. Monopoly, Cluedo, or Uno. Personally, if I had to let one stay, I think it's gonna be 30 seconds. 30 seconds is just fine. Who is next in our line? Immediately, what's your take?
I'm keeping Uno, ma'am.
Really, why?
Because I played Uno a couple of times, like at school with my friends, so like I'm actually used to it. Or because I've never played Monopoly or Cluedo, and I've played 30 seconds, like I think twice before, two,
Okay.
three times before. So yeah,
Monopoly is fun. The only thing with Monopoly is that it's long. It's such a long game, and I'm sure you guys have seen memes
that's why I
about
don't.
how
That's why I would never play it, ma'am. I don't like playing long games. I just
people
want to play
get
the game
very
and just get it
competitive
done.
in Monopoly. People like families will break because of Monopoly. So immediately you're actually saving yourself. So Uno makes sense. Uno makes sense. Thank you, immediately. Where's my little button? Okay, we have Adidas, Nike, Converse. I don't know what's happening here. Okay. Converse and New Balance. Personally, I feel like there's too many snobs with all of these shoes. So I'm going with Converse. If you are a shoe snob, I do apologize for calling you a snob. But some people are just like, oh, people are just too obsessed with shoes, I feel. So
Ma'am, I am obsessed with shoes and I hate New Balance.
I feel like New Balance is so trendy right now.
Ma'am, the
Super
only reason
trendy.
is because it's Gawker shoes. It's for the old ladies. That's why.
No, but like that's the style now. You know, like the old dad style. That's the style now. But anyways, Liacho, what is your take? Because you are next in line to answer this.
Ma'am, definitely my Nike, ma'am, because ma'am, I have like a lot of Nikes, ma'am, like at home, ma'am, like ma'am, and I feel like ma'am, like Nikes are more comfortable, ma'am. Like Converse, ma'am. Well, I have a lot of Converse, ma'am, and Adidas and New Balance, but I'm gonna definitely pick Nike. That's the best one for me.
The thing for me, Liacho, is Nikes are high maintenance. You know,
That's true, and they're more expensive.
right? Like
Yeah,
no.
but they're more comfortable, ma'am.
Yeah,
In
I
my
agree.
yes, ma'am. Thank you, ma'am.
Okay, and then Uma, you get to pick which one you want to answer. So I can go back to any one, or you can answer this one.
Um, can you go? I want to see the one before. I can't remember what it was.
So we
Yeesh.
had the board
I want
games, and then we
Monopoly or
had the
Starship.
subjects.
Yeesh. Like, I'll go with the board games. Yeah.
Okay, what's your answer?
Between 30 Seconds, Monopoly, and Uno. Because I played all three of them before.
Okay, so which one? You have to pick one, Uma.
I remember I cheated in Monopoly and you never knew. So, yeah. I'll choose
Starting
Monopoly.
fights.
I'll choose
Okay.
Monopoly.
Yeah, Monopoly is fun. I really like Monopoly. My brother and I used to play Monopoly. We used to play like one game of Monopoly for the whole of our school holidays. We used to like allow each other to take loans from the bank. So yeah, I really like Monopoly as well. Thanks, Uma, for answering. Let us look at some different ones. I immediately regret the questions that I put in because they're all super easy. But I want us to do this one before class ends. They've said that the shape below is 3/4 of a circle. The area of the shape is 120 centimeters squared. Determine the radius of the circle. Okay. Now that we've done that, I do see the hands. You both will get to answer, but I'm gonna do this one by myself. You both will get to answer one of the other ones up there. Right now, what I want you guys to see is, and I know I always get this from students, ma'am, but we don't know this. We've never done this, ma'am. And my answer to everybody is that you have. I think a lot of us struggle with combining or integrating our maths knowledge. And what I want you guys to know is that there is no topic in maths that is dealt with in isolation. When we're doing geometry, there's triangles, there's circles, there's Pythagoras, there's area, there's perimeter, there's all these different things, and they all get integrated. And even when we're doing geometry, we have to know how to do equations, we have to know how to solve equations. So maths is all integrated, and you guys need to work on your skills of taking all of the knowledge that you've got and combining it together to be able to do one question where all of your knowledge should be integrated. And so over here, yes, you may have never seen a 3/4 circle, but you have enough information to know how to do this. Immediately, I know the area of a full circle is pi r squared, but this is only 3/4 of a circle. So immediately I know I should be multiplying this formula by 3/4. Essentially, what we're doing is we are saying I need to take pi r squared, which is the area of my full circle. I need to divide it by 4 because now I want to know what is 1/4 of the area. And then I multiply it by 3 to know what is 3/4 of the area. And that is essentially the formula I've just created over there. Now that I've created this formula, I can go and I can now plug in my area that they've given me. I can solve for the unknown. First things first, I need to get rid of this 3/4 of pi. So what I'm going to do is I'm going to divide by 3/4 pi. And I'm going to divide this side by 3/4 pi. What happens is this multiplication and division cancels out. Tell me what you guys are getting when you put 120 divided by 3/4 times pi. What are you getting when you put that in your calculators? I'm also calculating with you guys. I am getting 50,93. Somebody confirm that we're getting the same answer. There we go. Thank you, Tando. And now, last thing, I want to remove the square, so I have to square root. If you don't know why I'm square rooting, go back and watch the equation series to see how we solve equations. Now that I've square rooted, I have that r is equals to, and what are you guys getting when you square root that answer? I am getting 7,14. There you go. So we've got 7,14, and it's not just 7,14, but 7,14 centimeters. They asked us to determine the radius. My R stands for radius. I've done what I needed to. Okay, I saw a hand go up. Do we have questions? Emilia, did you have a question?
Yes, ma'am. After the lesson, may you please like scroll back up to the question about the big rectangle thing, ma'am. After the
Sure,
lesson.
I definitely will do that. And then there's 3 minutes left. Uma and Itandile, you guys can I think let's do these two. Let's do D actually. D looks interesting. Let's try D. And I think maybe both of you can help me. Let's talk about it. You guys could actually talk to each other. How are you gonna do this question?
So what I want to do is get rid of the 3 meters, but you don't need the area, you just need the radius, so you can use that to get the radius.
Okay. So Uma, I'm gonna
Is
ask
it
you
the
to
full
calculate.
circle? It's like a full circle is equals to 3 meters squared. Not half of the circle, just the full circle.
Yes, it is the full circle. So Itandile, Uma has given us a plan. We're first going to calculate the radius, and then once we have the radius, we're going to calculate the circumference. So Uma, you calculate the radius, and then Itandile, you'll do the circumference, okay?
Yes, ma'am.
So I'm
Uma,
gonna
let's go.
say area is equals to pi r squared. The area is 3, so you substitute that in is equals to pi r squared. Now you want to get rid of pi, so you divide it by pi, and 3 divided by pi is 0,94. I mean 95, sorry, 95.
Hold on, let me check. 0,95, correct?
Now
No,
you
not pi.
now you want to square root afterwards.
0,95 is equals to r squared. Now we want to square root, yes?
And now I get 0,97.
0,9, round to 2 decimals, it will be 98.
No, ma'am. It's just 97 because my full thing on the calculator says 0.9746.
Okay, we can keep that. So let's go 97. I didn't round off my decimals from the previous step, but that's okay. Let's keep it as 0.97, and that is equals to R. So that's your section done, right, Uma? I take that as a yes. So if you guys are lost, let me tell you what just happened. They've given us the area of the circle. They asked us to determine the circumference, which is essentially the perimeter. But in order for us to calculate the perimeter or the circumference, we need to know the radius, because remember the formula for the perimeter or circumference of a circle is that it was equals to 2 pi r. So I need to know what my radius is to calculate that. So what we did is we worked backwards from our area formula to calculate our radius. Now that we have our radius, Itandile is going to take us through calculating the circumference. Itandile, come back.
Hi, ma'am.
Hi.
So, ma'am, the formula of the full circle, the circumference, ma'am, are we
Mhm.
using perimeter or using the area of a circle?
So remember, we have to calculate for circumference. So we're going to use the perimeter or circumference formula.
So, which is 2 pi r squared.
Beautiful. So my circumference is equals to 2 pi r and no square. Remember, when it's a circumference, we don't have the square. It's only when there's area do we
Yes,
have
ma'am.
a square. Mhm.
So, ma'am, so we're gonna say 2 pi, 2 pi, 2, 0, 0,97, which is r. And then, ma'am,
What are you
uh,
getting?
ma'am, I'm getting 2 pi.
I made a mistake. Uma, where did I make a mistake?
So, ma'am, you see where we got the radius? It's supposed to put meters squared.
Yeah.
Yeah.
Thank you. Itandila, are you getting this answer?
Ma'am, it's
Yes, yes, ma'am.
0.97, ma'am.
Oh, thank you, Uma. And Itandila, you said you got this answer. And so this is going to be
Yes,
centimeters.
ma'am.
So our circumference is 6,09 centimeters.
Centimeters.
Thank you, Itandile, and thank you, Uma, for taking us through this question and to the end of our lesson. It is Thursday, so as always, you guys are getting the quiz. I'm just gonna put that in the chat. There we go, guys. And then I didn't forget to scroll up to the other one. And then Tando, I see you said you used a different method, but you still got it right. That's okay. There are many different methods that you can use when it comes to these composite shapes and story sums almost, where there's area and perimeter involved. Okay. That is that. Bye, Zach.
Bye, ma'am. Enjoy your evening, ma'am. Good night.
Bye, Liako. Good night.
Bye, ma'am.
Please scroll up. Emilia, when you said a big rectangle and a small rectangle, were you talking about this one or the one that we actually did?
No, I'm not this one. Like,
Okay.
scroll more.
Yes, now I know the one you're talking about. There we go.
This one, ma'am. So, ma'am, this
Mhm.
week or last week we had like an activity that we did, and so like it was this similar to this. Like it was kind of like a house. So like it was a triangle, and then it
Mhm.
was two like rectangles. The one was the door, and then the one was the window. So basically, ma'am, we had to like there was a question where we had to calculate like the fraction that like. Wait, let me just quickly find the question, ma'am.
Okay. Um. Itandile, I know you also said you wanted to ask me a question after the lesson, so I don't forget about you either.
Yes, ma'am.
What makes me think I'm not in love? Is this a song thing again that I'm missing?
Yes, ma'am.
Okay, great, thanks.
Um, sorry, ma'am. So I couldn't find it.
It's okay. Can Itandile ask a question so long?
Also, ma'am.
Yes, ma'am.
Yes?
So, ma'am, we were given our take-home test for maths, and I was like kind of confused because, like, ma'am, it had Pythagoras theorem in it, and I didn't know how to find n. So, ma'am, it was like a full isosceles triangle, and then, ma'am, it was a square at the bottom.
What, like at the bottom, like a house?
Yes, ma'am. But
Mm-hmm.
then ma'am, on the square, it had a diagonal line.
Mm-hmm.
So, ma'am, and then it had Pythagoras theorem on one of them.
Like, yeah.
Yes, ma'am. And then, ma'am, um, on the isosceles triangle at the corner, it was written there at the top, ma'am. Sorry, it was written 102.
Mm-hmm.
And then, ma'am, on the diagonal line, it was written 25 centimeters. And then, ma'am, at the bottom,
Hold on.
now I can't see. Okay, on one of the sides, ma'am, on the sides, the side on the left is
Mm-hmm.
right, whatever. But then it was written, I'm not so sure now. Where is this? My life. Mm, it is written. Wait, ma'am, I had to find it first.
Okay, that's fine.
I found the question, ma'am.
Okay, Itandile, we're swapping over again. Looks
Yes, ma'am,
like.
it's fine.
So,
Okay.
ma'am, like 5.1 said, calculate the area of the front wall without the door and the window. So, like, I calculated that. And then
Hold on.
5.2,
Calculate the area of the front wall without the door and the window. So basically,
wait,
you calculated full area and then subtracted small window and or big door. Yeah.
yes. And
Mm-hmm.
then 5.2 said, what fraction of the wall is taken up by the window and the door? Oh, also, ma'am, by the way, the window, it says the sorry, the diagram shows a front view of an A-frame house. The window is 1,24 meters wide and 0,62 meters high. The door is 1,06 meters wide and 2,12 meters high. So then
Okay, hold
5
on.
points.
This is way too small. Let me try this again, and you're gonna have to give me all these measurements again. Okay, so let's do this. So we have a
The wind.
house.
So,
We
ma'am, like
have,
it's a
sorry, give me a second. We have a house with a roof, and then we have a little window, and then we have a door, correct?
yes, ma'am.
Okay, so give me the measurements again.
So the window is 1,2524 meters wide and 0,62 meters high.
Mm-hmm.
And then the door is 1,06 meters wide and 2,12 meters high.
Mm-hmm.
And then 5.1 says calculate the area of the front wall without the door and the window.
Mm-hmm. So you were fine with that?
Yes, ma'am.
Okay, did they give you the length of this walls?
The um no, ma'am. Oh
So
wait,
how,
yes they did, ma'am. Sorry, it's so like the width, the breadth was 4,23 meters, and then the height was 3,65 meters.
so this whole thing here was 4,23, and then the height was.
3,65.
So was this just the height of the walls, or does it include this roof?
No, ma'am, it's just the wall, ma'am.
Okay, cool. So you
So
knew
I
how to
was
calculate this area here.
yes, ma'am. So
Mm-hmm.
then 5.2 says what fraction of the wall is taken up by the window. So, ma'am, like what I did was I said after calculating the area of the wall without the window and the door, I
Mm-hmm.
then said area of the door. I mean area of the like the front wall
Mm-hmm.
minus the area of the door plus the area of the window, and then yeah, that's what I did.
So that would have been your answer from 5.1, right?
Yes, ma'am.
Now, if you were to calculate this fraction, the easiest way to do it is first to make it a percentage and then change it to a fraction. So when we're asking ourselves what percentage is taken up, what percentage of this wall does the window and the door take up, we first need to know what is the area of the window and what's the area of the door. So give me what your answer was for the area of the window and the area of the door. Do you
So,
have it
ma'am,
with you?
yes, ma'am.
Mm-hmm.
So the area of the window was, I said length times breadth
Mm-hmm.
equals to 0.62 meters
Mm-hmm.
times 1.24 meters, and
Mm-hmm.
my answer was 0.768 meters squared.
0,7, and so let's round to 0,77. Cool. And then we also have the area of the door, which you got. It would have been 1.06 multiplied by 2.12, and I am getting 2,25. Did you get these same answers?
Yes, ma'am.
Cool. Now we want to know what fraction of this door and window is what is the fraction of it out of the whole wall. So what you want to do is you want to add them up. You're going to say 0,77 plus 2,25, and that is going to give us what? 2.5.
Um,
Mhm.
it's gonna give us 3,02.
Beautiful. What we also need is we need the area of the full wall, which would have been 3.65 multiplied by 4.23, and that would be 15,44. You got the
Yes,
same
ma'am.
answer?
Mm-hmm.
Now, to calculate the fraction, all we have to do is say that the door and window is 3,02 out of 15,44. So this is sort of already a fraction because my door is 3.02 centimeters, or I think it was meters. So this should be meters. So my window and my door is 3,02 meters squared out of a total of 15,44 meters squared of this entire wall. Does that make sense?
Yes, ma'am.
Then all you have to do is sort of simplify this. So to get a fraction, you could then, what I would do is I would multiply this, I would multiply the top and the bottom by 100. And what that would do is it would remove my decimals. Do you see that?
Yes, ma'am.
Then once my decimals were removed, I'd find my highest common factor, and I would divide both sides, or the top and the bottom, by that. Makes
Yes, ma'am.
sense?
Yes, ma'am. Thank you so much, ma'am.
Pleasure.
Enjoy
And
your
then
weekend, ma'am.
you too. Itanila, are you still here?
Yes, ma'am, I am.
Mm-hmm. Did you get your stuff?
Yes, ma'am, I did.
Okay.
So, ma'am, it's a triangle, isosceles triangle with a square at the bottom. Then it's cut
Mhm.
diagonally, and the line it cuts diagonally is 25 centimeters. And then the side of the Pythagorean triangle, the angle triangle, is 9 centimeters. Then, ma'am, the bottom is 8.
Okay, so that's that. Then they told you this is that. They said this is 25
Mm.
centimeters. They said this is 102 degrees. And what was 9 centimeters?
9 centimeters was on the side.
Here
Yes, ma'am. And
Mhm.
then the bottom was
was
X.
X. Mm-hmm.
And then, ma'am, the corners of the isosceles triangle was N. And that's where I got confused. Because they're saying I should calculate the size of N, and I
Mhm.
don't know what's N.
Okay. This is geometry, Tandile. What is the sum of angles in a triangle?
Sum of angles in a triangle it's equal the side of the like basically the triangle is equal to 180 degrees.
Right. So let's add all of our angles. 102 degrees plus n plus n.
Plus, yes, ma'am.
What's my reason?
Sum of angles in a triangle.
Sum of angles in a triangle. Beautiful. Simplify this for me.
120 plus 2n is equal to 180 degrees.
Mm-hmm.
Then, ma'am, we say 2n is equal to 120 degrees minus 102.
So where are you getting 120 from?
102, sorry, ma'am.
Yes, so 180 minus 102.
Yes, ma'am.
Oh.
So 2n is equals to 78.
Mm-hmm.
Then divide both sides by 2.
Mm-hmm.
Then 78 divided by 2 is equals to 39.
There you go. Do you see that?
Yes, ma'am.
And can you see what I mean now when I say there's nothing in maths that's done in isolation? You thought you were supposed to do perimeter, you thought you were supposed to do Pythagoras, maybe area, but actually this is just plain old straight up geometry of triangles. Do you see that?
Yes, ma'am.
Cool. So I want you to always open your mind when you're doing these questions. If what you think you're supposed to do is not helping you, open your mind to the rest of the things you've learned in math, because it's usually that we've learned other tools, but we're just not thinking of it because we think, no, we're not doing
Yes,
that
ma'am.
topic here.
Yes,
Okay,
ma'am. Yes, ma'am.
cool.